Good day to you, geography students. This is the first video lecture for the semester for physical geography. This is the introduction to Earth. In this particular session, we will take a look at the four different topics that are listed on the screen. And then there will be two other brief video lectures in this session, or I should say in this module, for introduction to physical geography. Now, by now, you have undoubtedly viewed the short video on the home page, and you should be at least partway through the orientation module. Quick review: what is geography? Geo and graphein, from the Greek, meaning to write about the earth. And what can you write about the earth? Many, many different things, as you see here. Now, that doesn't tell us what geography is. What is geography? Let me give you some other pointers here. Geographic themes, a place, location, region being a number of places that have some similarities and they're near one another, so we can group them all together in a region. Human and earth interactions, and then movement not only of humans, but also movement within the physical realm. Putting that all together, we can come up with a definition of geography. I like either one of these. My own personal preference is the first one, but that doesn't mean that that is any better than any others. So it's a study of the spatial variations and relations of physical and human phenomenon on the earth. One of the basic ways in which we study geography is to use the scientific method. This is a methodology that is used throughout the scientific world, not only in the physical sciences, but in the social sciences as well. Some observations are taken, and we want to try and explain what we are seeing and why there are interactions that we observe. Well, we come up with an idea using some logic, and we have an idea of how things are working together. Taking that idea, we then do some experimentation, some measurement, review, and do more experimentation and measurement, review, etc. for several times, and then we come up with a hypothesis. This is not an educated guess, but it is based. It is an explanation based on our observations. We go through and do more experimentation, and if the experimentation does not support our hypothesis, then we go back to square one. If it does support our hypothesis, then what we do is we ask other people to take a look at our hypothesis to see if they come up with the same results. They will then take our methodology, our observations, and do their own experimentation. Because, as you know, what one person sees, another person doesn't, and what one doesn't see, another person does. So they review it. It's called peer review. Now, if the reviewers decide, well, things don't really look that way that you are proposing, and several other reviewers say the same thing, well, then we trash that particular hypothesis and go back to square one. If the reviewers say, oh, that looks pretty good, and then more reviewers look at it, and more reviewers look at it, and it goes on through time, and it's supported by more experimentation and measurements by other reviewers through time, then it becomes a theory. Now, science also has viewed particularly the physical system, but also the cultural system. I'm already ahead of myself. The physical world as well as the cultural world in terms of systems. That is, interrelated things and their characteristics that interact. For instance, De Anza is a part of a community college district, the Foothill De Anza Community College District. It is a system, it's an educational system that exists in Santa Clara and San Mateo counties. And it is separate and distinct from the California State Legislature. You know, the legislature and the Foothill De Anza Community College System are not the same. They are distinct, and they're distinct systems. In this case, cultural systems. Does the legislature affect Foothill De Anza? Yes, it does. Does De Anza affect the legislature? It can, but to a much lesser extent. All right. Now, these systems can interact. There are two basic kinds of systems. Closed system, which is completely and totally cut off from the environment, and then an open system, which is not cut off from the environment and in fact interacts with the environment. Closed systems are only found in the laboratory. They really do not exist in nature. Although one could argue that the universe itself is a closed system. Now, I may be wrong in saying they don't exist in nature. If any of you can come up with an example of a closed system in nature, other than the universe, please let me know, because I don't know everything. An open system, clearly an open system is not self-contained. It does interact and is affected by the interact with and is surrounded by the environment. An open system, there are inputs, there's actions and outputs. In this case, we have, well, look at that, a Prius. So we have both gasoline and electricity that are inputs here. We have some other inputs as well. And then action. The gasoline and electricity are energy, and they result in outputs. Their conversion results in outputs, that is movement, heat, gases, used tires. Try and get rid of a used tire. Anyway, it's an open system. Inputs, actions, outputs. The system, the car itself is a system. Another example of an open system in nature is a forest biome. There are inputs, that is sunlight, various types of gases, mineral nutrients, water, and then there's action. Sunlight and carbon dioxide and water are used by plants in the process of photosynthesis to manufacture carbohydrates, i.e. food. It's plant food for the plant, and also tissue for the plant. There are outputs from the forest system. It puts out oxygen, carbon dioxide, which that's what it took in. It also heat. And then when trees die or leaves die, that's organic matter. Animals feed upon the plant, and eventually they die. And that's part of the entire system. So this is an open system. Now, systems also have feedback. A feedback loop is a concept in which one of the outputs of the operating system will result either one, in inhibiting or slowing the operation of the system, or two, enhancing or speeding up the operation of the system. If the output slows down or inhibits the system, it's called a negative output. If it is a output that enhances or speeds up the system, then it's called a positive output. The example on the screen is an excellent example. Sunlight coming in and hitting dark ocean water in the Arctic. that sunlight is absorbed. It causes the water to heat up. And what happens when water heats up with ice floating on it? Well, some of the ice is going to melt, which is going to expand the amount of ocean water, which means that there'll be more heat energy that will be absorbed from the sun, heating the water more, resulting in more ice melt, resulting in more open ocean, which will result in more solar energy being absorbed, resulting in more ice melt. That is an excellent example of a positive feedback. Again, geography and definition. Keep this in mind. Now, the open system of the Earth. Yes, the planet Earth is an open system. As we receive sunlight, we receive cosmic radiation, and we receive matter from space. The system consists of 4 different environmental spheres. Now, we're primarily talking about the surface of the Earth here. The atmosphere, the lithosphere, the biosphere, and the hydrosphere. The atmosphere, of course, is the gaseous envelope surrounding the planet. The lithosphere, taken in this more colloquial usage, is the hard substrate, the solid substrate of the planet. If you're into geology, you know that the term lithosphere has a specific meaning in geology, which we won't get to until a little later on in the quarter. Biosphere, of course, being all living organisms, from redwood trees to elephants to blue whales to bacteria to COVID viruses, etc. And then the hydrosphere, water in all 3 phases, whether it's gas, liquid, or solid. And they interact, as this little diagram shows. We take the atmosphere. And what's in the atmosphere? Oh, we have a bird. Well, we have part of the biosphere inside the atmosphere. We have a cloud. Well, what's the cloud made of? The cloud's made of 1, water vapor, 2, liquid water, 3, ice, water in all its phases. Now, when you see a cloud, you're seeing ice or liquid water. You're not seeing vapor because you can't see water vapor. It's invisible. Now, take the soil. The soil is part of the lithosphere. Inside the soil, there are tiny pore spaces. And in those pore spaces, there can be air, there can be water, and then burrowing through the soil, there can be worms or other disgusting creepy crawlies, if you're not into studying those fascinating things. So we have then, I think, 2 examples of interaction. You say, wait a minute, what about the lithosphere and the atmosphere? Yes, what happens when the volcano erupts? What happens when there is a haboob, a dust storm? That's the lithosphere in the atmosphere. So these various different environmental spheres, they all interact with one another. And then finally, I give you the open system of the planet Earth. And that will conclude this particular introductory lecture on physical geography.